Today in this video, I will show how TL494 PWM controller base modified sine wave inverter works. This is the second part of the video on modified sine wave inverter. In the first part of the video, I showed how I build this inverter circuit and explained in details the function of each stage and components. Here I will show measurement of the output voltages and signal waveform at the outputs of each stage. I will start by placing DC and AC voltmeter across the stage's outputs. The first stage outputs 310 volts to 340 volts high voltage DC output from the high frequency signal generated by the first TL494 together with the rest of the first stage components. Next, I will place an AC voltage meter across the load at the second stage. The second stage is used to convert the high voltage DC voltage from the first stage into 50/60 Hz 220 volt AC. This is the inverter output applied to the load. Also, I will add a DC voltmeter to measure the voltage applied at the DTC pin, design control pin. The pop connected to the DCC pin is used to control the dead zone to shape the output waveform to look like a sine wave. This is what makes the circuit modified sine wave inverter. Now I will run the simulation. The voltage at the DTC pin is 0.75 volts, and the output voltage of the first stage is approximately 315 volts DC, while the output of the second stage, that is, output of the inverter, is around 220 volts AC. Now I will show the signal waveform, Vt, after the transformer, the signal waveform Vo at the output of the first stage, which is the high voltage output, and the signal waveform at the inverter output across the load, the lamp. I will delete the voltmeters because I don't need them anymore. I will connect the previous wire signals to oscilloscope. Let me set the oscilloscope settings. The yellow waveform is the transformer output signal Vt, which is high frequency square wave. The blue waveform is the high voltage DC output Vo after the capacitor filter. The pink red is the modified sine wave inverter output signal, VA, which is inverted VB, across the load. That's it. This completes the measurements of the TL949 based modified sine wave inverter. Don't forget to watch the first video, which will help you understand this video. Thanks for watching. See you in the next.